record this so I can post it later. Welcome to the final data puzzle webinar series. For those of you that are new, welcome. A data puzzle, I'll kind of give that background story of the data puzzle in just a moment, but data puzzles are kind of a data analysis resource that we've developed that incorporates ambitious science teaching practices, weaves them both together, authentic data, ambitious science teaching practices to help students make sense of phenomena. And so with that, tonight we're going to go through the framework, how these ambitious science teaching practices are embedded in this resource. We'll look at some data and talk through some different facilitation moves, again, so you leave here tonight confident in your ability to use this resource if you're interested in that. So we'll start by just introduce myself and our team. So my name is John Griffith, and I'm a curriculum developer for the Cooperative Institute for Research in Environmental Sciences series, which is cooperative at the University of Colorado Boulder, where there are scientists at NOAA and the University of Colorado Boulder are a part of this cooperative with series. And so my job is to work with these scientists to bring their contemporary research into K-12 classrooms. So it's a really exciting job on a number of different levels. For me, my background is in geology, spent a number of years studying past climate and past climate variability in Alaska for my graduate degree, transitioned into an 8th grade classroom and taught for 6 years in a classroom, and then moved to Denver, chased my partner to Denver, and secured this job, kind of the best of both worlds, where I get to work with scientists and engage in contemporary science, but really my passion is working with students and teachers in education. So it's a great spot for me. Working with me on this project, my supervisor, Dr. Anna Gold, and we're super fortunate to have some amazing collaborators at the University of Colorado Boulder. Dr. Melissa Bratton, co-author of Ambitious Science Teaching. It's been amazing to get to work with her and to truly embed these practices into this resource. With her guidance, it's been really amazing. And also helping support this effort is Dr. Carrie Winger, who's a curriculum designer and facilitator for Inquiry Hub, kind of a storylining organization run through this University of Colorado Boulder. Should also acknowledge that there have been a number of different educators that have helped develop some of these data puzzle resources and have provided feedback on these resources in the framework. So I want to acknowledge them as well. So this is our team. And I wanted to give a quick background of this story. So when I was hired in 2019, my job was to develop resources focused on this Mosaic Arctic research expedition. So one of the largest Arctic research expeditions ever conducted. And we developed quite a following through the resources we developed, including virtual reality tours that you see on the screen now. And once the field portion of the expedition ended, there were a number of teachers that reached out that wanted to continue to engage their students in Arctic science using contemporary data sets, so reaching out for data. And that's something that we at Series, especially in my position, having access to so many scientists, I felt that I could contribute to the education world by being able to work with scientists to find these curated data sets. So spent a couple of years developing Arctic related resources and really bringing in contemporary Arctic data into those resources. And in looking for other resources and tools to do this, collaborated with the folks at Data Nuggets who do awesome work to make a Arctic related data nugget. With that, we wanted to do a little bit more than what was included in the data nugget structure. We wanted to include these contemporary research practices, ambitious science teaching. We wanted to infuse some different data visualizations and videos. And so out of that, this data puzzles was born, where we're bringing authentic data into a resource, utilizing bits of data nuggets framework. If you've ever heard of the NSTA daily dues, you'll see parts of that. and ambitious science teaching infused into this data puzzles resource. So that's the story. And for those of you that may or may not be familiar with ambitious science teaching, this is a pedagogical framework with principles, practices, and tools to support meaningful and equitable science education. So what does that mean? It means just really being mindful of how you're planning for engaging with important science ideas. One thing that we really learned in our work with the Arctic is you can't just jump into talking about Arctic climate science with students. These are complex concepts and topics, things that students haven't heard about before. So you really need to be mindful of, when you're talking about the Arctic, for example, students likely they might not even know where the Arctic is, or they might not know what it looks like. And so before you start talking about concepts related to the Arctic, bring them to the Arctic. Maybe you can elicit some student ideas about concepts that are similar to what you'll explore in a later activity. You want to plan for how you're going to use these science ideas. Really important to elicit student ideas as resources for sense making. And so we'll talk about what that looks like in the data puzzles. But a real key part of the data puzzle resource is using student language, student experiences, student ideas as resources to help them make sense of this complex phenomena. Third part of these ambitious science teaching practices, having students, working with students' ideas to support ongoing changes and refinements in thinking. So again, you need to elicit those ideas so that you can work with those ideas later on. And the final practice in ambitious science teaching, pressing students to construct evidence-based explanations. So all 4 of these practices are infused into the data puzzle resource. And with Melissa's permission, we've made a small change to this framework, and that is we've swapped the eliciting students' ideas quadrant and the planning for engagement with important science ideas quadrant. For the purposes of data puzzles, we've already done the planning for you. So the first part in this resource, as we'll engage with here in just a bit, is eliciting students' ideas. And then the second part will be helping students identify important science ideas. So just wanted to note that at this time. So in data puzzles, again, noting this swap, eliciting students' ideas and identifying important science ideas. The first part of all data puzzles, and again, there are 7 data puzzles tonight. We're just highlighting one, the Megafires data puzzle. The first thing we want to do before we dive into these complex concepts is to help students connect to the scientists' research and complex concepts by eliciting students' ideas about a similar or related scenario or event. So in this case, right, when in thinking about the Arctic, if we're talking about the Arctic albedo, the reflectivity of the Arctic, we might want to focus, we might want to provide a scenario that is a little bit more simple, something that students may have engaged with in their everyday life. Perhaps, we look at a picture and there is a rooftop where it's black on one side, on the other side, you can see people painting the rooftop white, and just putting that out there to students and saying, what do you notice? What do you wonder about this image? Why might they be painting this rooftop white? Eliciting those ideas from students before we take that and apply it to the Arctic, where there might be declining sea ice and a change in albedo or reflectivity as a result of that. So trying to elicit ideas about a related phenomena. Once you've elicited those ideas, that language, those experiences, then you're going to dive into a text with students where you're going to connect students to the scientist features in that text and their work, be an interactive reading. So this is going to have visuals, some guided questions, videos, other things embedded in this interactive reading. Students will also look for an investigative or scientific question that's presented in that text, and they'll make a prediction about that question based on using evidence and reasoning that they gain from the text to make that prediction. In this third practice, supporting ongoing changes in thinking, students will test their prediction by analyzing and interpreting authentic data. And this last practice, they'll construct explanatory models about that investigative question, utilizing their own ideas and language, utilizing evidence they gain through the text, utilizing evidence from the graphs that they've analyzed to construct this explanatory model. And again, this is going to be some sort of annotated sketch. So these are the 4 practices of ambitious science teaching and how they're infused in the data puzzle. And we're going to engage with each of these practices tonight in the context of this Megafires data puzzle. So without further ado, let's get into it. Megafires, are these rare occurrences, or is this the new normal? Before we engage with the eliciting student ideas practice, the first practice in the data puzzle resource, I wanted to take us all quickly to the data puzzles website, and I'm going to add this into the chat right now. Datapuzzles.org. And so this is our website. We'll be doing a little bit of an overhaul this summer. But the 7 data puzzles that we have in our collection right now are in this data puzzle collection tab here at the top. And so we've got a number of different Arctic related data puzzles. Last week did a webinar about the mega drought in the Colorado River Basin. And tonight, the 4th data puzzle down from the top, this Megafire rare occurrences, or the new normal. For each of the data puzzles, you can see there's a teacher guide, a slide deck, and a student worksheet. There's also an answer key, and that answer key can be found in the teacher guide. So if you click on that link, pops up is this teacher guide, and all of the teacher guides are the same, or look the same, I should say, for the 7 different data puzzles. So they all have some setting the stage, some background text at the top, and then a lesson overview about what students are going to be doing in that particular data puzzle, the question they're looking to explain. The data puzzles, for the most part, are meant to be 2-day resources. And I've broken up those 2 days into 4 distinct parts. The parts are named based off of the ambitious science teaching practice that will be infused into those respective parts. So the eliciting students' ideas, about 20 minutes. Here's what they'll do. Part 2, when the students identify important science ideas, they're going to be reading that interactive text and doing a couple of things. And so these parts are described in more detail on pages 3 and 4. The second page of the teacher guide is an instructional overview table where you can see the standards connections, the question that we're going to be investigating, and the materials, the slide deck, the student worksheet, the answer key, they're all linked there. Below pages 3 through, it looks like 5 here, again, each of those parts that were briefly described on the first page are fleshed out in more detail and provide some pedagogical moves and some instructions about what you should be doing during each of these parts. And at the end here, I provide some additional teacher resources. Look for this to be fleshed out even further. These data puzzles take a surprisingly long time to create. And in developing them and creating the story, you happen upon a lot of cool resources. And so I try to link those resources here at the bottom of the teacher guides or in different places in the slide deck, just so that to encourage you to learn more yourselves about Megafires, and again, encourage you to take these resources however you want. I feel like the data puzzles provide a fun structure to maybe introduce your classroom, in this case, to Megafires. And then there's so many different ways that you could take this and explore this with students that hopefully the additional resources help inspire that and provide you with resources that you might be looking for. It might be helpful. So with that, we're going to dive into this first part together. So this would be what you would start with your students. This is a teacher facing slide. So in this practice, eliciting students' ideas, your goal is to elicit student ideas about an opening scenario. So images, a video or demo, it might vary, that has similarities to the science investigation presented in the data puzzle. So your job here, you're trying to pull out student experiences, ideas, and language that can then be used as resources later on in the data puzzle to help the students make sense of the complex science phenomena presented in the resource. So facilitation strategies, I really want to emphasize this at the start. This part one, eliciting students' ideas, is not included in the student worksheet. Nothing in the student worksheet says right here, or there's no question space for that. And one of the reasons for that is I know that when I was in a classroom, I had a warm-up prompt that students would write in their science notebook. You could use this eliciting students' ideas part as that warm-up prompt. We've had other teachers just facilitate discussions as they relate to this opening scenario, whether it's the question or video that's included as the opening scenario, just a kind of a think, pair, share. And other teachers use small whiteboards and small groups to have students respond to the opening scenario, whether that's a noticing and wondering or sharing an experience they had. So a couple of different ways to facilitate this first part, but know that it's not included in the student worksheet. For this particular data puzzle, the question that we would be posing to students is, have you ever built a bonfire or another open fire? Where were you? Did you gather your own sticks? Was the fuel, these sticks, was that wet or dry? Tell us the story. And so for this, I would probably encourage you to have students respond to this, or at least think about it individually before they share it in a small group and then a large group. And what you're doing here with this opening scenario is you're trying to have students, you're trying to key in on certain things that students might be saying. Like, I would expect them to say, like, we had a lot of fuel. They wouldn't use the word fuel, but maybe they had like a Christmas tree that they wanted to burn, and it was a huge fire, and it was because they had a lot of sticks or a lot of wood. You want to maybe ask, like, how was that, wet or dry? Note that you wouldn't give this away for your students, but what we're looking for here to help later on in the data puzzle is we want to hear things like lots of wood, lots of fuel, lots of dry fuel. Those are words and experiences and ideas that are going to be important in the data puzzle later. And so wanting to connect that to student experience in the context of a bonfire in this opening scenario. So after you have this conversation with students, help them make the connection between bonfires and wildfires, and the fact that the materials that you want when you're building a bonfire are the same materials that can lead to these massive wildfires. Many students have either heard of or unfortunately have lived near some of these large wildfires in the Western United States and elsewhere in the United States. And some of the largest fires, scientists use the term megafires to describe some of the biggest fires. We'll use that opening scenario in this slide as a segue to introduce Dr. Natasha Stavros, who is like kind of the featured scientist in this data puzzle and who helped curate the data set for this resource. So through the opening scenario, segueing into like, oh, how you make bonfires, that's similar to how these large wildfires start. Natasha is somebody who studies the occurrence of frequency of megafires and factors that influence them. She makes and analyzes mathematical models to predict the likelihood of future megafires and to help people better plan for and respond to these extreme events. So hopefully you can see how we got from that opening scenario to introducing Natasha. And then we're going to send students off to read this interactive text, either together as a whole class, the partner, individually, to learn more about Natasha's work. So once we've introduced her, this is a student or a teacher facing slide here. We're going to dive into the interactive text in the student worksheet. This is maybe when you distribute the student worksheet as well after that opening scenario piece. And the goal of part 2 is to help students identify important science ideas that are introduced in this puzzle plot interactive reading. So your job, your goal here is to help students connect science ideas from the reading back to that opening scenario. Students are going to be summarizing key ideas in an annotated sketch, and students will identify the question that Natasha is investigating and make a prediction about that question. So some facilitation strategies, because there are some videos embedded in this text, it might make sense to read this document aloud, depending on what grade level you're teaching and where students are at. Maybe it makes sense to read it and have students read it individually. If you use close reading strategies in your classroom, we'd encourage you to utilize those same strategies with this text. You're the experts. You're in the classroom. You're with your students. So however you help students make sense of text, we'd encourage you to utilize those strategies. So when you distribute this student worksheet and send students off either to read the text individually or as a whole class, again, we're trying to learn more about Natasha's Megafire research. Student tasks when they're reading, we're asking them to circle the investigative question that Natasha's trying to answer and then underline similarities that they find between the reading and the opening scenario. With that, it's really hard to go any further unless you all take a few minutes now to check out this puzzle plot text. So I'm going to give you all Google timer. I'll give us 5 minutes. We'll do 5 minutes. 5 minutes now. If you can click on the link that I just added to the chat, it will take you to this student worksheet, asking you to read the text, take a look at some of the images. Maybe you can start to envision how you might facilitate this second practice, how you might have students read this text again individually or as a whole class. And we'll meet up again here in 5 minutes. Thanks all. All right, I'm going to go ahead and stop this before we get any sort of ringing. Hopefully, you got a chance to check out the student worksheet a little bit. Obviously, 5 minutes is too short a time to really dig in, but hopefully you got a sense for what we're trying to do here. Early on in this puzzle plot text, introduce this term megafire. Know that there are many different ways to define megafires, and in this particular resource, we're defining megafires based on size, and they are larger. They're the top 5% of fire events, the largest top 5% of fire events that is studied in this 1984 to 2019 data set, larger than 20,000 football fields in size. And the question that we're trying to investigate in this resource is, how has the number of megafires in the United States changed over time? Then there's some background information about text or about megafires, how they're destructive. But also we want students to appreciate that wildfires are also beneficial, and humans have lived and thrived and used fire as a positive tool throughout the North American West for millennia. And so wanting to and reinforce the point that, yeah, we have a lot to learn from indigenous peoples that have used fire as a positive tool, and that when European settlers came in and began these fire exclusion practices, we saw a big shift in our forests to those that were much more open to forests that have now a lot more fuel and a lot more smaller trees and lots of different types of fires. And in this resource, we don't get into fire regimes, but wanting to use kind of some images here to show the effects of fire exclusion and how the forests become choked with fuel. The last bit here, wanting students to appreciate that temperatures are rising. So not only are humans impacting forests with fire exclusion practices, but also we're contributing to the rise in global temperatures, which increases the rate of evapotranspiration, or the amount of water lost through plants and soils. And this has implications for the drying of fuel. So through this text, really trying to drive home that human practices of fire exclusion and our contributions to the greenhouse effect, enhanced greenhouse effect, and global warming are things that we want students to pull out of this resource. Will be important in terms of making sense of how the question, how has the number of megafires changed over time? So one thing that I wanted to spend some time with is this particular figure that's included in the text. We've been back and forth about how to best present this. This is kind of an anomaly figure, and I've modified this figure from a paper that Natasha published. And so, we want students to look and make a connection between changes in temperature and changes in the dryness of fire fuels. Now, in trying to, it's this figure again in the paper is much more complex, but basically these are projections for 2031 to 2060 with respect to a 1979 to 2020 baseline. So how are temperatures and fire fuel dryness, how are our model projections for temperature and fire fuel dryness different in 2031, 2060 with respect to 1979 to 2020? So there are a couple of things depending on your audience. One, you could just kind of mention these are projections for 2031 to 2060 and have students look at the darkness of the colors. Darker colors mean a greater change, a greater increase in temperature in this time period with respect to 1970 to 2020. Darker colors in fire fuel dryness, again, drier fuels in the future. And you can see that the colors really match up here. Where we see rising temperatures or greater changes in temperature, greater increases in temperature, you also see drier fuels. Now, one of the things that makes this figure more challenging is the units of these color schemes I've removed and instead tried to add some text down here just to provide some context. So on the right image here, this lighter color beige represents no change in dryness from 1979 to 2020 compared to 2030 to 2060. And the fuels in the darker red would be 2 times drier. Now with temperatures, we're talking about a much different scale of change. These lighter purples here or pinks would be 12 times higher temperatures in 2031 to 2060 with respect to the 1979 to 2020 baseline. And the purples would be 17 times higher. So depending on who your audience is and how much detail you want to go into it, the big take home here is that temperatures in the future are expected to continue to rise, and that's going to generate some drier fuels across the Western United States. So that figure, there are also some different videos. This particular video at the end of the text talks about how there's a future for mega droughts are projected for the American West. So kind of going with that same image. And the point here again, and we've got fire exclusion practices leading to a lot of fuel in our forests and human emissions of greenhouse gases and our contribution to global warming are drying out these fuels. After we read that text, look at those graphics, watch some videos, give students an opportunity to just reflect and have a conversation with a partner or as a whole class. What ways are current forest conditions in the United States similar to conditions you might want if you were asked to build a bonfire? And so trying to go back to that opening scenario in that text, we're really making clear there's a lot of fuel and it's really dry in the forest. And those are that's exactly the type of fuel that you would want if you were building a bonfire or a campfire. So now we want to really, we've read that text, we've watched some videos, we've had some discussions. We want to give students an opportunity to summarize these important science ideas by completing a couple of different tasks. And so we'll go to the answer key now to show you what that looks like. Again, all of these data puzzles are the format is the same. There's some text, and then these questions are more or less the same, but tailored to each resource. So in this identifying important science ideas, one thing that we really want students to pull out here is why forest fuels have become drier over time and really key in on change in temperature. And so here's an example of an annotated sketch that students may come up with in terms of in the past, we've got our forests, some trees, some grasses. We can see that there's lots of moisture. There is some water being lost through evapotranspiration. But it's very different in the present. We have less moisture, more water is being lost, represented by longer red arrows or larger red arrows through evapotranspiration. And so it's this change in temperature. As you can see, the thermometer is a little colored in here. Warmer temperatures, higher rates of evapotranspiration, a little less water. So that's what we're trying to get students to come up with in this particular annotated sketch. That will become important in their final explanatory model. This is kind of practice for that final explanatory model. The questions Natasha is trying to answer here is investigating how has the number of megafires changed over time, and then students will make a prediction about this question. So this concludes that identifying of important science ideas. There's that interactive reading, some videos, some graphics to discuss. And then students will draw and describe about an important science idea, important concept, find the question, make a prediction for the question before we dive into the data analysis piece. So I expect that part, the identifying important science ideas, part 2 there, to take 40 minutes or more, depending on how you facilitate that in your classroom, but that's probably going to be the most time consuming part of this resource. Once students have made the prediction for their question, now it's time to test those prediction against authentic data. And so some different facilitation strategies here. One that Melissa really emphasizes, and something they learned in their research before writing the Ambitious Science Teaching book, is it's so important to talk about the graphs before you give students the freedom to go interpret them on their own. One strategy that Melissa likes to talk about is having students identify a particular point and describe that point. So sometimes rather than just describing the X and Y axis and looking at the labels and the intervals, just challenging students to look at a particular point and see if they can explain what's going on. And hopefully with that kind of prompt, they then themselves look at those axes. Now, certainly there's a time and a place for looking at those X and Y axes and talking about them as a class, but maybe before you do that, point out a point and have them try to explain that. Again, this is where, whatever you're doing in your classroom and strategies that you utilize, we trust that you're the experts and you're gonna do what works for you and your students. So that means students could work individually or in pairs to analyze this data set, or as a whole class if needed. A lot of teachers we've worked with like this whiz-wim strategy, what I see, what I mean. So annotating the graph directly, what they see, what they observe, and what they think it means. So really like annotating the graph on the student worksheet. Again, whatever works for you. The goal here is we're testing our predictions by analyzing and interpreting some authentic data. So in this is a slide directly from that slide deck. We are encouraging you to challenge students to talk with a partner, talk as a whole class about some specific, in this case, bars in the bar graph. So this graph we're looking at is the number of megafires in the contiguous United States, the number of megafires from 0 to 800, and we're looking at these megafires over 4 distinct time periods. So you can see from 84 to 89, there were fewer megafires, maybe around 125 megafires during that time period. You compare that to the 2010 to 2019 time period, more than 600 megafires in the United States. This group looking at this graph, pretty clear that the answer to this question, how has the number of megafires changed over time? We're seeing a pretty dramatic increase in the number of megafires over time. You wouldn't tell that to students as you're talking through this particular slide. That's for them to figure out in questions 4 through 7, where they're asked to identify patterns, explain those patterns, and then revisit their prediction for the investigative question, how has the number of megafires in the United States changed over time? They need to describe whether this data set confirms or refutes that prediction and why. So that piece in this particular resource, I'm not sure how long that will take for your students. Depends on where they're at and their ability to analyze a particular data set. I will say that I think that I am going to create a middle school and high school version of this resource. There's a different data set that Natasha provided that breaks these megafires out even further, knowing that they represent the top 5%, the largest 5% of fires over this 1984 to 2019 period. That's how they're defined in this resource. Some megafires are even larger than others. So I do have a data set where we can break down this even further in terms of like, here are the largest megafires and potentially have some other questions with that. Shelly, that's a really great question. Shelly asked, the first block is only 5 years. Do we not have data for 1980 to 1983? And my understanding is that there is that data set. We don't have that data set, or Natasha wasn't able to provide that data set. And so that is something that I'm glad that you pointed that out. And we kind of hope that students point that out. And it's like, maybe this this isn't reflective of what was actually happening. We're missing a few years. So could it be that there were, you know, many more megafires in this 84 to 89 time period? Or sorry, if we broke this out into a 1980 to 1989 time period, such that each time period were 10 years, maybe there would have been more megafires here. So definitely something that's important to point out or discuss. And like Shelley pointed out here, hopefully your students point that out. So now that we've gone through the opening scenario, we've pulled out student language, student explanations, student experiences as it relates to how they build a bonfire. We've connected that bonfire to wildfires and megafires. It's explored conditions of our forests that are much more dense. There's lots of dry fuel, conditions suitable for these megafires. We've looked at a data set that supports the prediction. If your prediction was the number of megafires has increased over time, that data set supports that. And now it's time for students to finalize these new understandings and ideas as they relate to the investigative question by constructing an explanatory model. In this case, it's an annotated sketch. So in this, students can construct these models individually or in pairs. Leave that up to you. And we have in the slide deck with this resource an option to co-construct a gotta have it checklist with students. So this is a public record where students work collaboratively to share ideas, share concepts and evidence that they think absolutely has to be in a final model that explains that investigative question. Concepts you absolutely gotta have in that model to explain how and why the number of megafires has changed over time. And so you could do, Melissa talks about how this public record, this gotta have it checklist, they're best utilized in a classroom when there's disagreement amongst students or pairs about what should be in this final model. And so in this case, I might also use some sort of gotta have it checklist. I know that I've added a few things in the key, for example, an arrow to show changes in evapotranspiration, among some other things. So it might be worthwhile having a conversation with students about how they might use those different symbols to explain how and why the number of megafires has changed over time. So kind of leaving it up to you and your experience and expertise with your students in terms of how much scaffolding they might need. But for me, this is a final model that I've included in the answer key. And again, what's fun about these final models is they're going to look different for every student. And that's why it's so fun to give them this opportunity to share what they know in a little bit of an artistic way. So in this case, past, present, future, we're looking at differences in temperature. Again, we know the future temperature projections are expected to be much warmer than they are at the present. So these thermometers represent those different temperatures, and you can see same key as what students saw in that first question: tree, grass, moisture, evapotranspiration. What's different here, you can see in the past we have less fuel, fewer trees, fewer grasses. Present, I added more trees, more grasses, more fuels because of these fire exclusion practices. In the future, perhaps more fuels, or maybe less fuels if we do some fire management practices, some thinning, some prescribed burns, let natural fires go a little bit longer. So in terms of the future and the amount of fuels in the forest, I'm not sure that students really have enough information to say whether the future fuels will be more or less dense. Past, we got some more moisture, some smaller arrows to represent less evapotranspiration. The present, a little bit less moisture. These arrows, I think I wish I'd made them a little bit longer. But these arrows are supposed to be a little longer than in the past to represent more water being lost to the atmosphere through evapotranspiration. In the future, you can see less water, larger arrows, more water lost through evapotranspiration. I would expect students to also include fire, which I didn't add in this particular illustration, but it's fun to see what students come up with for these. But the key takeaways here, right? We've got these fire exclusion practices leading to an increase in fuel in the forests. A changing climate is making conditions dry, and these conditions are expected to unfortunately continue in the future. And so we may see even more megafires in the future, given our current trajectory. The final piece of these data puzzles, I always have some sort of digging deeper question, whether that's solutions based or some social justice type of question. In this case, what are actions forest managers could take or are taking to reduce the number and impact of megafires? So lots of different ways you could take this with your students. And I add some videos at the end that talk about, how wildfire managers are working with indigenous peoples and using traditional knowledge to help form these plans together. And there are some other videos there that you could check out that are in the slide deck as part of this resource. That is it for this particular data puzzle. So we've gone through, right, the opening scenario, eliciting ideas about that, how to build a bonfire and student experiences with that. We've connected the student experiences to the conditions in the forests in the United States, dense forests, really lots of dry fuels. There are videos, there's that graphic in there, some graphics in there to spend some time with. Students make a prediction about the investigative question, how has the number of megafires changed over time, and test that prediction by looking at some data, and then put all of that together in a final explanatory model. So that's the resource, and we're looking for teachers to pilot this resource and provide some feedback. Again, this project, we're excited, it has some funding, and so we're excited to email you a $50 Amazon gift card if you use this resource and complete a feedback survey. If you're interested in participating in this, interested in piloting this resource, I'm going to add a link to the chat right now. Please complete this Google form. It's funny, I got a bit.ly, but then I went to my drive. Yeah, Shelly, you could share this with other teachers. I think I would like for those teachers to contact me before they got going. I think that what we've learned, this is my email there, what we've learned is that it's really important that either a teacher would watch this webinar or spend some time with me. We found that teachers tend to skip particular moves or practices and don't get the most out of these resources if there isn't a little bit of training first. So I'd be happy to talk to teachers that are interested in piloting this, and there's my email there. Also, if you want a 1-hour certificate, PD webinar certificate for being here tonight, also click that link in the chat. So it's not only a pilot Google form, but it's also a webinar certificate Google form. So you put your name in there, your email, say whether or not you want a certificate. We'll send those out to you on Monday. Also say yes or no whether you're interested in piloting it. No window, Allison, in terms of when we're looking for teachers to pilot this and provide us feedback. The only window being we'd really like it to take place in this spring, the second semester here, this spring. So May, if you're on the East Coast, I'm in Vermont right now, it goes until June, like any time between now and the end of the school year would be great. Also want to put a plug in while you're all here, and Shelly, if you're willing to share some of this stuff, really appreciate it. I'll be running, I've got a number of different units that incorporate ambitious science teaching practices. They follow, basically, it's called model-based inquiry. It's a storylining approach to the development of unit materials. And so this Future of Forests unit that I have developed here, students construct models to explain how landscapes recover after wildfires. So lots of the same practices that you see here. We elicit student ideas, students construct an initial model. It's kind of a diagnostic assessment for how landscapes recover after wildfire. And then we look at a number of different interactive tools, US Forest Data Explorer tools, NASA satellite data sets, do some games, look at some case studies, and basically we come to the conclusion that post-fire succession patterns are changing in a warmer, drier world. So if you participate in this 2-day workshop, you get a certificate for 10 hours of PD, and you have the option to purchase 1 grad credit from CU Boulder. And exact same instructional framework, this model-based inquiry storylining approach. This is kind of the way that I like to, this is how I like to teach. So these are the types of units I like to make. Students explore, they trace carbon through the Arctic food web to predict how the decline in sea ice is going to impact Arctic organisms, large and small. And so they develop initial models. We gather evidence through a series of different investigations that include our GIS story maps and some photosynthesis investigations, some case studies, and students construct final models to explain how that decline in sea ice might affect Arctic organisms, large and small. This one I'm running at the end of July. Again, 10 hours of PD, option to purchase a grad credit for those that participate. So yes, please, I would love to work with anyone and everyone that's interested. So I will reach out through the Eventbrite on Monday with this recording. I'll also include these different links to these different workshop opportunities. I can right now, I'll add this slide deck to the chat, and all of the resources are hyperlinked in this slide deck. So you should be able to access those resources right now if you're interested. And again, I'll reach out on Monday with the recording. Those of you that are interested that completed that Google form will reach out with the webinar certificates, and you can expect to hear from me for those of you that are interested in piloting this resource. So that is the scoop. That's it for tonight. I really appreciate you all being here.